Hi, welcome to another version of the Code Coder. I am the Code Coder. I am trying to make you great, help you innovate. Today we are in Xcode. We are working in Playgrounds. We're going to talk about a Swift topic named functions. And let's get going. So I open up the Playground and you'll see that I already have it formatted for today's lecture. And we should just get talking about it, okay? All right, so first thing that you have to understand is that there are two types of functions. A primitive type that you've been working with all along. Something like the print statement was just like a primitive type that Apple created for us. And I could say Swift is awesome. All right. And so we've been working with that for a long time now. And it is not a definition, it's just a call. And the call, the definition was actually made by Apple, and we don't know how their print function is actually written. Actually a black box case. But you have written these types of function calls before. In your math classes, you always had something called f of x. Your teacher usually gave you that and said x equals 3, solve it. And inside the function, there was something, in here like this. So you had something like x plus 1, equals 4, solve for x, or something like that. Okay, and actually it would have been more like something like this. It would have been 5 plus x equals x, or something like that. Okay, and you had to solve for it, and you always were able to do it, but you didn't really know why you did it. You knew how to bring the number in and put it in for x and try to solve it, but you never quite understood kind of why you were doing it. Today you will. F actually was really short for function, so it looks more like this: function and x, like that. That's what it should have been. I don't know why they don't expand it. Probably easier to write, and it doesn't, have to spell out the whole thing. And inside here are just parameters. Now you only had to put integers in your parameters before in your math class, but now you got to put in all kinds of data types. You got to put in strings, bools, integers, doubles. You can put in arrays. You can put in classes, class objects. Okay, so functions are going to be a little bit different, but you have dealt with them before. Okay, so that's a nice intro. All right, or maybe not a nice intro. Maybe now you're more confused. All right, so now let's talk about a custom function. So a function that you write, you come up with a name with it, you put in the parameters, and you can do that in Swift. Okay, so I'm going to comment this out, and then I'm going to write a normal one down here, and I'm going to just make a perfect haiku. Okay, so yep, and there it is. Okay, so now this is what's called a class or a function definition. Okay, because I'm defining what it does. It's like the blueprint of the function. And in here I could just do something like, I could use the native, oops, you see how code completion now knows that you have another function in there called print haiku. When code completion fires, it fires both custom classes and primitive classes. We just want the print that Apple put together. I like when you put the quotes, it automatically puts the quotes, and it wants you to put something in there. So we will put input. We're going to make a perfect haiku here. Okay, so there you go. And then print again. So now the second one in line. And let's just do, this is, okay, there's that one. And let's just complete our haiku. Okay, so there you go. So now that's a custom function. Now, up here, when I played it, you could see that Swift is awesome automatically come in here, but when I play this function, nothing happens. And that's just because this is a function definition. Okay, it has to be called. Okay, so let's go ahead and call it. So let's go print. There it is right there. Hit IQ, print a IQ, and there that is. We'll comment this out so you don't see this one. Okay, and we'll run just this one. All right, there it is. And that is a perfect haiku and a perfect custom class. All right, get that? All right, let's continue on. Now, there's more things that you want to talk about with functions. I'm actually going to comment this out so we don't see it. And let's talk about the parameters that you put in. We're going to first start with a string parameter. So here's how you do it in computer science. You name the function. Okay, it's called invite, and you declare the function by putting the reserved word func in front of it. All right, and in the parameters where we said in your math class you put x, we put in the name of the parameter so we can make it very synonymous with what we're storing. So we're going to store guest names, and you can't just put the variable name like x. You got to actually say this is the type of data that's it's gonna store, and we put in the type string. So it's name colon and then type of data. Make sense? Then the curly brackets, and then you could print all kinds of stuff. You could put other functions within functions. So we put all these print statements in here. We're just going to write a letter to our guest. Dear guest, I'd love you to come to my birthday party. It's going to be Saturday. Da 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 da. Okay, there you go. So let's go ahead and invite Kathy and Megan. So I'm just going to now make the function call. There it is, and I could put Kathy. Right, and if I go ahead and play that, you'll see that I run Dear Kathy, I'd love for you to come. So it runs. Okay, so it sends Kathy up to this variable. Anytime I print that variable out, it has Kathy. Okay, let's do another one. Let's do Jim. Okay. Okay, and Jim. Here you go. All right, and so if I run that, you'll see I have an invite to Kathy and Jim. See, so functions make things, especially repetitive tasks, you put it in a function so you can do it over and over again. Some people like to call that abstraction. Okay, so let's, it's still a little slow because of one at a time. It's all right, so I'd like to get even faster, and functions can make you very fast. What if I didn't send one parameter at a time? What if I send multiple parameters? And you could do that in an array. In our earlier lessons, we talked about an array and how it's instead of being in the diamond lane with one driver, you could be in there with a bus full of drivers. Okay, so let's send a bus to our invite so that we can invite a bunch of people. Okay, so here's my new function. All right, so it's function invite, and instead of just bringing in a string, you can see now because of the staple brackets, I'm going to bring an array of strings. Okay, a bunch of them. And we're going to call them all guest. But take a look what's in the body of this function. For guest in all guest, invite guest. So wait a minute, I have invite, two invites. Are they different? Well, the colors suggest they are. Okay, and you are making, or a function is different if it has different parameters. Okay, it's called overloading the function. All right, so this one has guests, and this one's bringing in an array string. Okay, an array of strings. All right, so basically what happens is we need an array of strings to show you first. So here's our array of strings. Okay, friends. Put all these people in there now. Now, not just two, there's 6. All right, so let's write that invite call. So I'm going to invite, and you can see that there's an invite already there in code completion, so I'll use that. And the string I will go ahead and, or the array I will send in is called friends. Okay, there you go. So now I set all those up to invite, which is sent to all guest. So now you know how to loop through an array. This is how you do it for guest and all guest. It calls this invite. So where is this invite? Well, of course, this is the invite up here. Okay, so let me comment these two out and see if I play this one to see if we could get all the invites set at one time. There you go. And you can see I did. Okay. There's all the invites. Kathy, Megan, Maddie, Julie, Sophia. Got them all. Okay. So pretty cool. All right. So yeah, let's comment that out and let's keep going. Some people might ask, well, can you send 2 parameters? And it's right here. Yeah, you can. Okay. So here's how you send 2. So now let's say people are coming to the party, but some are reserving and some aren't. Why don't we send out another email or another letter, either asking people to RSVP or thanking them for coming. We'll have a good time. So we're going to do one we're going to do two. We're going to send two parameters. Okay, one, we're going to send a string for the guest himself, and then another parameter, an RSVP, but not of type string, of type bool, true or false, whether they've reserved yes or no. Okay, and then in here we can do a conditional statement. If they have RSVP, that's why we did a bool, true or false. If it's true, print, I'm so excited you're coming. Else, hey, can you please let me know by tomorrow? Okay, so let's go ahead and send that message call to it. Okay, so again, I'm going to make the call now. Send message, there it is. The string, let's start with, I put in my notes here, Julia. And here, let's put true. So let's say Julia already confirmed. Okay, and let's do another one for Asher. Send message to Asher. Remember, these have to be in quotes. We're sending a string. All right, and then let's say Asher didn't send us anything. All right, and then let's go ahead and run that and see what we get. All right, so we run it, and as you can see, Julia, who did RSVP, she gets a message, I'm so excited to see you this weekend. We'll have a great time. But then Asher, hey, I hope I can see you. Can you let me know by tomorrow if you're coming? Come on, Asher, get with it. Okay, so that's kind of cool, right? So I'm sending two parameters to a function. So let's comment that out and move on to argument labels. Okay, so I love argument labels. We talked about Swift being very attention to details. Apple's a company that's very attention to detail. What they're trying to do is make programming language look like a language. This is actually going to make your programming code look just like plain English. It's very beautiful. Okay, so what they're going to allow you to do is put an argument label in there. And this is just so when you look at your code, it just speaks English. Okay, so in the definition, you'll see that you could put a to friend, say hello to friend. Okay, that's the definition. And when you make the call, you have to say the same thing, but look how nice it says, say hello to Colin. All right, so let's actually do an example and you'll understand this better. Okay, so now going back to the same party, people have come to the party, they've dropped off gifts. Now let's send a thank you note. Okay, so here's a thank you note, to guests for gift. That already is starting to look very English-y. Okay, very nice structured sentence. Okay, and let me read it again. Send thank you to guests for gift. Okay, and of course we got to put the data type string and two strings we're going to send. But watch the call. Watch how beautiful this is. Okay, watch send thank you note. Okay, and I'm going to go Megan. Okay, and let's say she gave us puzzle books. Make sure this is in quotes. There you go. So now let's read this. Send thank you to Megan for puzzle books. It's just straight English. Doesn't get any cleaner than that. And if I go ahead and run it, dear Megan, thanks for coming to my party and for the puzzle books. It was so great to see you. So beautiful, right? Okay, and that's what Swift does. Now, take a deep breath, those that are already programmers. Oh, I don't want to add more to my code. That doesn't look nice. That doesn't look codey. You can actually still, let me comment this out, you can actually still do it without argument labels. So here's an example of that. So I don't put any argument labels in, and I'm just going to get a volume of a box. So in order to suffice Swift that you don't have argument labels, you just put these underscores, underscore, 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 and then you go, the volume of the box is side 1, side 2, side 3. So let's go ahead and make that call. Okay. So I'm going to say volume. And I'll just say side 1 is 3, 4. And if I run that, you're going to see that you get the volume of the box is 60. Okay, so there you go. The call, the definition has just these underbars, and then volume, when I make the call, I can just go 3, 4, 5. Really simple. So they still have the old way. Take a deep breath, programmers. Don't have to do argument levels you don't want, but you can see with kids or people that are learning code, this is going to be really nice. Okay, all right. So let's talk about return types. I don't know what happened to my notes here, but there's a return type here. And I'll just do this. I had that kind of nicely formatted before, but must have erased it. All right, so there's return types. So let's talk about return type functions. Okay, there's two types of functions really. Okay, I know that I said there's parameters or primitive and custom, but now once you understand that within those two, there can be two different types. One with return values and one without. Okay, so let's say your son comes to you and says, I'm going to go to the park. He runs the park. You don't expect him to bring anything back. Okay, he never said he's going to bring anything back. But if I went to my son and said, go to the store, get some milk, bring it back. Now that's a function where he's going to go away, go to the store, and come back with something. Well, functions have the same things. The ones I just showed you were void, or we just printed stuff to this. We didn't want to store the information anywhere. But now we want to store the information or save it. Just like when I get that milk, I'll put it in the fridge. So when you have a function where you're going to return something back and you're going to store it, it's called a return type. And here's how you write them. You just see this arrow right here. You put that arrow and then say, well, what's coming back? In my example, it'd be milk, but in this example, it's going to be an integer. Okay, now inside the body of the function, you have, whatever function you want to create or action you want, and then at the end you'll say, what do you want to return? And we're going to return the volume, which is side 1 times side 2 times side 3. Okay, so to call it, all I'd have to go is let volume of box equal volume box 653. I send that. Goes into side 1, side 2, side 3. It makes a calculation and returns volume. Now remember, I always say it's right into the left, so volume's sitting here, and it's going to be stuck in this volume called volume of box 1. And if I play that, you're going to see volume of box 1 is 90, and volume of box 2 is 64. That's because I'm sending these things, and I'm actually printing out those boxes. Okay, so 64 is what returning there. Okay, so that's a return statement. Big topic. I know I just kind of breezed by it, but let's talk a little bit more about the return statement. You can actually run a conditional statement now that you have it stored in a variable, the calculation of the box. Well, this is nice because now I can basically compare things. Okay, so if volume box is greater than volume 2, print box 1 is bigger. Else, if volume box is less than box 2, then print this one. So it's now an else statement. So now when you catch stuff and use return statements, you have this variable stored with the information, you can run these conditional statements. So let's go ahead and run that. Okay, let's see here. Let's run statement. I think I forgot to run this statement. Oh, okay, so go to here and run this, and you can see that you have box 1 is bigger. So it ran the entire statement, it returned it, put in volume, we ran a conditional statement against it, and then I played it, and then it says box 1 is bigger. Okay, there you go. So that's why you want to return to a variable. So now we could do some conditional statements and do something with the data. You can also do conditional returns. You return 2 different types of data. So here's a func average of, all right, and you got an array of integers coming in, and it's going to return an int. All right, so if the scores in the array are greater than 0, return the sum of the scores. If they don't have anything, then just return 0. So that would look like this. Average of 86, 78, 98, take this array, send it up to here. Okay, it now does a calculation. Basically, if there is something in the array, go ahead and print the sum of scores, okay, or the average. And then if there's nothing in the array, just return a 0. And by the way, you don't even have to put anything here if you don't want. It would still run just fine. But just for aesthetics, remember, aesthetics, Apple likes everything looking good. All right, and so you can just put return 0. Okay, so here's the average of this. If I run it, you'll see it's 86, and if I run this one, it's 0. Okay, so going back over what we learned today, pretty awesome. You know there's 2 types of function, primitive and custom. Okay, you now know that there is, you can put parameters in your function, and you could also put multiple ones. You can even send arrays. You can use argument labels to make your function just read like English, which was very cool, very pretty. You don't have to use argument labels. And you could write, if you use return statements, you could write conditional statements against the constants. And you can also do conditional statements for your return types. Okay, so that's it for today. Big topic, functions. Okay, here to make you great, help you innovate. See you next time.